Hello everyone, welcome to the Innovation Lab. So this is going to be a quick video to address some of the concerns that I've heard from you guys that some people have been having with these converters, and I honestly believe that some of those concerns could have something to do with these boost converters overheating and not being properly cooled. So that made me realize that I've not really stressed to you guys the need to have an efficient cooling system. In this case, it's going to be a fan because it's the cheapest way to keep your system cool. I have not stressed on that, and I'm making this video to kind of go over that. And in this video, I'm going to give you guys show you guys what I usually do, and also give you guys a few options for fans that you can use and how you can configure them. All right, so let's get to it. But before we get started, I would like to mention that all my videos are based on honest tests and reviews, and I'm not actually affiliated with any manufacturers or vendors, or my videos are not sponsored. So everything that I tell you guys or make multiple videos about these guys, these boost converters or the buck converters, is all based on an honest opinion and test. So the same thing applies to these fans that you're seeing here. So everything I tell you guys is based on the parts that I've used, and I was impressed about them, so I'm making this video to recommend that you guys try the same thing. But also always do your research before you purchase anything from anybody. So contrary to the comments that I've received from a lot of people about how their DC to DC boost converter, when they put a load on it, or maybe they're doing some high current charging, I've had a different experience with these converters. So I've had a lot of these converters for many years. As you can see, the one I am using on my DIY wall power supply here, which is also my battery charger, I've had it for many years, and as you can see, I never run this charger without having that fan running and cooling the converter that I'm using in there, as you can see. So, and I've had many of them. This one here I've had for almost 3 years now, and I use it for a lot of my tests and to do different kinds of things. This one here I am planning to use for my my actual charger design that I'm working on. I'm gonna be making that video very soon, hopefully in a couple weeks. And these two are the 1800 watt version, while this guy here is the 1200 watt version of this converter. So as you can see, the 1800 watt version has a fan in the back, and the heatsink is actually bigger. But then I don't rely on those. I also add my external cooling fan to it. So this one got damaged because I was doing some tests, because I was experimenting on something and I damaged it. So it was on purpose. It was not the fault of the converter, it was my fault. So that kind of surprises me when I hear the story about people losing these converters. So in one of the videos I made, I also talked about the limitations of these converters. I made it very clear that these converters, out of what I found out when I was doing the testing, that the converter is rated for an input voltage range of 12 to 60 volts and the current limit, an input current limit of 30 amps. So what that means is, to be able to get the full rated power out of these units, you have to really push that input voltage to the upper limit. So if you're only using a 12 volt source coming in here, if you do the math, 12 times 30, you're probably going to only be getting less than 360 watts out of here on the output. So if you're one of those people complaining that if you put a load on this, it doesn't drive the load or it gets damaged, make sure that you're paying attention to exactly what I'm just saying right now. If not, you're going to have some issues. So I'm basically making this video to stress on the use of fans. So if you follow everything I'm saying, I don't think you will have any issues. So as some of us may be wondering, why do we need to keep our systems cool? Why do we need additional fan even though these units come with the heatsink. And actually the 1800 watt version of this DC to DC boost converter comes with a small fan, as you can see here, in the back of the heatsink. So what I've realized is that the heatsink is good, the additional fan is good, but it's not enough to cool the system to keep it functioning efficiently as it's supposed to. So there are multiple components on these converters that dissipate a lot of heat. So as you can see in here, maybe not so clearly, but you can see the power MOSFET in there, and it dissipates a lot of heat. You can see the rectifier diodes, the two rectifier diodes on the left, and they also dissipate a lot of heat. And on top here, the power inductor, as you can see here, the toroidal inductor, also dissipates some heat. So there's a lot of multiple points on these converters that we expect that they will dissipate a ton of heat, especially at maximum load. So as you begin to approach the maximum power rating of these devices, you will expect that there will be lots and lots of heat generated. So the same thing is applicable to the 1200 watt version. So this one even doesn't have any fan at all added. So when you go to Amazon or eBay, the vendors always add a note for you to add additional external cooling system like a fan if you're going to be running these devices at the maximum ratings. All right, so that's the reason why you need the fan, to make sure that you keep the system cool, to keep the drive MOSFETs cool, to keep the rectifier diodes cool. And basically when you do that, it will increase the efficiency that you're getting out of your DC to DC buck converters or boost converters. So even the buck converters are actually a little bit worse because they come with these tiny little heat sinks, so they are not going to be enough. If you're only using this for like maybe 1 or 2 amps, maybe that's good, but this guy is actually rated for 15 amps. There's no way that you will rely on these heatsink if you really plan to, you know, source 15 amps out of this device. So basically, don't be surprised if they burn out or if they are not functioning how they are supposed to. So actually, in one of my charger videos, I used this DC to DC buck converter as a battery charger. And what I was realizing was when I approached the higher limits of current draw from this guy, I was losing output regulation and the heat sinks were heating up. So, but right after I added a fan, the DC to DC buck converter maintained the output regulation even at higher current draw. So this goes to show that, you know, having a fan or a cooling system going over these guys is actually quite very helpful. All right. So now let's talk about the fans. What kind of fans do I have here and where can I get them? So as you can see here, so these fans are these are called RGB LED fans. So RGB means that it could display multiple colors, and they have LED lighting in them. And these are actually originally designed for PC cooling system or cooling fans. I believe I bought these fans last year. The price of close to $20 for a pack of 6. I know right now with inflation and everything, the price probably has doubled. I would not be surprised. So, but the cool thing about these fans is they actually come with a pack of 2 control units. So you have the option to plug in all 6 fans to this one unit, or you can plug in as many as you want or need into this one unit. So for the fan design, again, as I mentioned, the fan was originally intended to be used in PC. So it came with connectors that basically all you had to do is plug in to PC connectors and everything will be fine. Since I'm using it in a different configuration, I had to basically kind of hack the system, and we'll go over that. I'll show you guys the schematic and the wire connections and how I had to configure it to make it work. So the other kinds of fans that I have here is, as you can see here, this is a 12-volt fan that I pulled from an old power supply unit. So if you're working on a budget and you don't have a lot of money to spend on fancy LED fans, so you can, you know, kind of look around and see if you can find something like this. It will also work and give you the same effectiveness. So I'm looking over here, you can see these guys are 12-volt fans. You can connect them directly to your 12-volt battery or 12-volt system, or you can use a voltage regulator. They are very low powered fans, and this, I actually got a pack of 6 of these guys for only $9 from Amazon. So that's another option. The only thing is, in a situation where you can use only one of these to give you the same cooling or something that comes close, you may have to use like maybe 5 or 6 of these. So, and the advantage is you can use this for a more compact design. Meanwhile, this can only fit in a bigger design. So for these fans here, and I'm going to show you guys after this, I'm going to show you guys this schematic, and it's very simple. So as I mentioned a little bit earlier, so this fan comes with this control unit. So this control unit, as you can see here, comes with a cable with 4 wires. So, and I will break it down in the schematic to show you guys which wires are the ground and which wires are the 5-volt positive and which wires is the 12-volt positive. So the only thing you will need to do to adapt it to your design will be to, if you're using a 12-volt battery or 12-volt source like I am doing here, you can connect the 12-volt line directly to the control unit, but the 5-volt, all you have to do is to grab like a linear regulator, like what we have here. This is a linear regulator that we connected to the 5-volt line, so that way we will also provide the 5-volt that the control unit needs. All right, and I'm going to show that in the schematic. It's a simple schematic, you can easily follow it, and the only thing I'll say is make sure that it again goes back to the topic of this video, which will be cooling. Make sure that if you're using a linear regulator, that you mount it on a heat sink, just to make sure that it doesn't burn out, because linear regulators, as most of us know, make a lot of heat and they're not very efficient. So unless if you have another option you can use is if you have like a small switch mode buck converter that you can use to step that voltage down from 12 volts to 5 volts, then you can use it as well. All right, my friends, that's it for this video, and I hope that this video will help you to address some of the overheating issues, or help you address some of the reasons why you have been losing your converters. And if you like this video, if you got some good information from this video, please make sure you give it a thumbs up to help our channel grow and to help trigger the YouTube algorithm. All right, my friends, I will see you guys in the next video, and I wish you guys success with your projects.